is the tutorial for Chapter 7, Section 2, titled Finding Cubic Roots. And so cubic roots are similar to square roots, but this time instead of finding just two numbers that multiply to make a value, we're looking for three numbers. So what you'll notice is that there's a small little 3 up in the upper left-hand corner of the radical sign. And this is called our index. And our index tells us how many roots. This is the number of roots we're looking for. So again, roots are the numbers that multiply to make the radicand. And for instance, if the number was, let's say, 27, I would be looking for three numbers that multiply to make 27. So the common mistake is people like to divide the radicand by 3, but that would be wrong. That would be finding three numbers that add to make 27. So three numbers that multiply to make 27 would be 3. See, 3 times 3 times 3 multiplies to make 27. So the cubic root of 3, or of 27, is 3. So that's what we're looking for, and this is a perfect cube, and so that's what we have, and we're going to be finding some edge lengths on the first problem. So it says the volume is 125 cubic meters, and when we've got a cube, that means if I wanted to find the volume, I would have to multiply the area of the base, so s times by the height. And so that's going to be 3 s's being multiplied together, so the cubic root of s. And then my volume is 125 cubic meters. And so if I wanted to find the edge length, I'm going to have to take the cubic root. And what that does is it cancels out the cube symbol here, because if I have to cube something, or if I bring something to the third power and then cube it, I get right back to the number that I started with. So I look for the numbers that multiply to make 125. The common rule is that if it's an odd number, you're going to end up having an answer that's odd as well. So it's an odd number and it ends in a 5, so a good bet would be 5, and that's the number that it ends up being. So make sure you put your units in there. 5 meters is the answer. So for this one, we are looking for three numbers that multiply to make 0.001. And so whenever we have 1 as the last digit, the common rule is that we want to find numbers that multiply to make that. So we think of either like a 1 times a 1 or a 9 times a 9 makes 81, but then we have to multiply by one more 1, or one more 9 in that case. So in this case, when I take the cubic root of both sides, I end up getting 0.1. And you see it works because if I multiply by 0.1 times 0.1, that gives me 0.01. And then if I multiply by one more 1/10, that gives me 1 again, followed by 2 zeros. And so we have, or actually before 2 zeros. So the 2 zeros and then followed by that 1. So the answer for the side length would be 0.1 or 1/10 of a centimeter. And so here we have a fraction. So we're looking for three numbers that multiply to make 1/8. And so when we do that, we can treat these as two separate radicals. We've got the cubic root of 1, the cubic root of 8. And so when I take the cubic root of 1, that's 1. Cubic root of 8, well, it's an even number, so try even numbers, and 2 would be that answer. So we'll write down 1/2 of a yard would be our answer. So on this one, we're looking for three numbers that multiply to make 1,728. Again, it's an even number, so you're going to try even numbers. So the answer is going to be even. So when I do this, I need a benchmark, and a good benchmark is multiplying by tens. So if I did 10 times 10 times 10, that would be 1,000. So I see the cubic root of 1,000 is 10. And so another one that's easy to come up with is what 20 to the third power is. So 20 to the third power is going to be 8 followed by 3 zeros, so 8,000. So you can see how 1,728 fits in between these two numbers, but it's closer to 1,000. So I'm going to try an even number that ends up being close to 10. So the next even number would be 12. So try it. So 12 to the third power would be 144 times by 12. So when you go ahead and multiply this out, you do get 1,728. So that tells us that the answer is 12. So when we're dealing with cubic roots, we can have negative numbers because we can find three negatives that multiply to make this, an odd number of negatives. So the key is, again, we're using our benchmarks. And so we saw that the cubic root of 8 is going to be 2. The cubic root of 1,000 is going to end up being 10. And so I see that 512 is between these numbers, a little closer to 1,000 than it is to, well, it's actually pretty close to both numbers there. So we'll say that in order to get there, though, we're going to end up trying to probably pick a bigger number than 2, but smaller than 8 or smaller than 10, and it is an even number. So I've only got these choices, 4, 6, and 8. I'm going to go with 8 to start with, and then I'll try it. So it's going to be an even number, at least the denominator is, and they're all going to be negative. So I try negative 1/8 times negative 1/8 times negative 1/8 to see what I get. Well, 8 times 8 is 64, and so when I multiply by 8, see I'm getting 32. Carry a 3, that makes 48, and 3 makes 51, so that does work out. So my answer is negative 1/8. So on this one, again, you can take the cubic roots separate, just like I could have with this one, but this one's a little bit trickier here. So 343, it's an odd number, so try odd numbers. And then the cubic root of 64 is an even number, so you try even numbers. And so we know that it's between 2 and 10, the answers, because the cubic root of 8 is 2 and the cubic root of 1,000 is 10. These numbers are in between those values. So our choices for this one, for being an odd number, are 3, 5, and 7, and 9. 3, 5, 7, 9. Our choices for this one, we know it's not 2 because it's bigger than that. So 4, 6, and 8. Well, we just did 8, so I know it's not that. So I've limited down to 4 and 6. And 64 is not much bigger than 8, so I'd probably try 4. So 4 times 4 times 4 gives me 16 times 4, which does give me 64. And so I know the denominator is 4, and now I've got to try to figure out which one this one is. Now, I know it's not 5 because it doesn't end in a 5. I know 3 times 3 times 3 was 27 because I just did that, so it's either going to be 7 or 9. And when I look at this, 5, 8, 512, well, that was 1/8. So 8 times 8 times 8 is 512. So I'm going to go with 7. I'll see if that works. So 7 times 7 times 7, so that's 49 times 7. And 7 times 9 is 63. And carry a 6, and that does make 343. So yes, that works. 7/4 is the answer. So let's take a look at some other types here. Here we have to evaluate the expression. So we're trying to find the cubic root of 8 first, and we saw that was 2. Then this 4 is right next to it, so that means I'm multiplying by that cubic root, and then I'm going to subtract that answer from 18. So I do order of operation, which is the roots, the radical, then multiply, and then subtract. And I got 10 as the answer here. Remember, the cubic root cancels out the cube. And so we're just left with negative 64. And then plus 43, since they're opposite in sign, we'll subtract. And we end up with negative 21. So I multiply 5 times the cubic root of 512. Well, we saw earlier the cubic root of 512 was 8. And so when I go ahead and multiply that, I got 40 minus 19, which leaves me with 21 in this case here. So we take a look at the next one, and this one says to evaluate the expression for the given value of the variable. So we're taking 64 and we're putting it in for these y's here. So we have the cubic root of 8 times by 64, and then plus, and then we've got 64. So we add these two numbers together, and that gives us, or actually multiply the 8 and 64, that gives me 512. Well, I already know that this cubic root of 512 is 8. I've done that a few times now. And I add 64 to that, and that leaves me with 72. On this one, I substitute negative 3 in for b, and for this b as well. So I've got negative 6 when I do that multiplication. So I'll show where I got that again. And so I did 2 times by negative 3. And then minus the cubic root of 9 times by negative 3. And so I got negative 6 again, minus, and then the cubic root of negative 27. So the cubic root of negative 27 is negative 3, and then I take away negative 6. And so taking negative 3 away from negative 6, I'll add the opposite there. It leaves me with negative 3 as the answer. Well, a couple more problems here. It says the volume of a music box shaped like a cube. So remember, the cube looks like this. And it says that the volume of this is 512 cubic centimeters. And so it says find the surface area of the music box. So we need to find the side length first. Since this is a cube, all sides are the same. So it's similar to that first problem that we ended up seeing. So I set the into the volume formula, s cubed, so the side length cubed, and I'm going to take the cubic root to cancel out that cubed symbol, and then I have to take the cubic root of the other side. So 512 again, that makes 8. And so I see that the side length is 8 centimeters. So if I wanted to find the surface area, so the surface area is going to end up being, well, there's 6 sides to a cube. If I go ahead and draw on the hidden lines here, you can see how there is 1, 2, 3, that's the one in the back there, 4 on the top, and then 5 as this front face here, and then 6 as this front face. So if I do 6 times by the area of one of the faces, so just s times by s, and that gives me what one of the faces is going to be. So 8 times 8, and then multiplied by 64, or no, multiplied by 6. So I'll do that work, and I have 6 times 4 makes 24, carry a 2, 36, and 2 make 38. So 384 centimeters squared is the surface area. This one, the pyramid, has a volume of 972 cubic inches. What are the dimensions of the pyramid? Well, our formula for a pyramid is 1/3 area of the base times by the height. So this is the area of base. And so the base is this x by x. It's a square. So it's x times by the height, which is 1/2 x, times by 1/3. And then this all equals the volume. Well, I know that the volume is 972, so I'll substitute that in. Multiplying the numbers here, I get 1/6, 1/3 times 1/2, and then times by x to the 3rd power. So I want to get rid of that 1/6. So the way I'm going to do that is I'm going to multiply by its reciprocal first. So if I do that, I multiply by 6. So I end up with 6 times 2 is 12. And carry a 1, that makes 42, 43, carry a 4, and that's 54, and 4 end up making 58, and so that equals x to the 3rd power. And so from this point, I now need to find out what that cubic root is. And so when I do this, this is a pretty big number, and so when I'm looking at 5, 8, 3, 2, I want to look at my benchmarks again. So I know that the cubic root of 1,000 is 10, and I know the cubic root of 8,000 is going to be 20. So I see that this number here is an even number, and it's in between these two numbers. So I know that answer is going to be bigger than 10, but smaller than 20. And 5,832 is closer to 8,000. So I'm going to end up trying an even number. So it's an even number, and I'm going to try 18 times 18 times 18. Well, if I did 18 times 18, that's 324 times by another 18. And when I go ahead and do this work, this is looking really promising here. 8 times 4 is 32. So you see how I got a 2 at the end? That's what this has as well. And if you continue on the multiplication, you do get that answer. So 18 inches is what x is, but they want the dimensions. So the dimensions, you have to say, well, would be 18 by 18, 18 inches by 18 inches, by, and then 9 inches. Where do I get the 9? Well, 1/2 x. And so 1/2 of 18 represents 9. So those are the dimensions of that pyramid. So those are the types of problems you're going to see on tonight's assignment. Good luck.